Hi doctors, my name is Chong Kat. Today I would like to share about the experiment set for variant training sample size of the equimetric predictions. The goal of the experiment set 4 is to analyze how the training sample sets impact the model performance. The experiment 4 will conduct 3 validations using the different training sample sets. First, we will use the best model from the experiment 1, which is the decision trees. Next, we will select the best features which is identified in the experiment 2. Finally, we will apply the boosting techniques to enhance the model learning performance across the different training sample sets. Before we share the result, I will introduce the methodology for the experiment 4. For our data sets, we have 8926 rows inside our data set. First, we need to split into the two sets. One is a training set, one is a test set. Training set contains 80%, which is we have 7140 rows, and the test set we have 1786 rows. Next, we split our training set into the 10 small groups. Each group contains 10%. And the test set is 100% for the validation purpose. For the first round, we just use the 10%, which is the 714, to train the models. Then use the test set to verify the model performance. When go to the second experiment, we add another 10%. So now the trained data is 714 times 2. So in total, we have the 1428 data set to train the models. Same, we use the test set to validate the model performance. Third, also add another 10% and also use the test set to validate the model performance. Until we reach the 100% of the training set and find out how many training sample sets were more efficient for the model performance. So we apply the experiment 4 methodology for each 3 validations. Finally, will allow us to determine the optimized training set sample is identified which experiment provide the better model predictions. Now I will introduce the result for the experiment once. On the left hand side, we have the table summarize the model performance. The column loop represent the percentage of the training sample sets. For example, 1. Actually 1 is represent 10% of the training set. 10 is represent 100%. The next column is the training site, indicate that the number of samples used in the experiments, following by the performance metrics. R2 is our primary score metrics, and then RMSE, MAE, MSE, and also time taken for the experiments. For the the last 4 column display is the core validation result with the CV equal to 5. On the right chart actually is the visualization for the table results. Okay, for the table summary, we can clearly to see that score will increase when the training sample set is increased. Additional, MSSE, MAE, and the MSE decrease. The result indicate that if let's say we use more training data set, the significance improve the performance of the experiment once. So when the training set reached the 100%, the R2 score achieved the higher value, which is the 0.8896. Next, experiment 2. The best selection is the forward selections, and the same thing here. We show the training data sets R2 value is higher when we increase the data set to the 100%, and the RMSE, MAE, and the MSE will reduce. In summary, the R2 score we will get is 0.8937. Last but not least, experiment 3. The boosting AdaBoost regressions is the best method to improve the model performance. More training data set we provide, the R2 score were getting more higher. And finally, we can get 0.907 when the training set achieved 100%. And same things, RMSE, MAE, MSE were reduced also. In summary, more training data we have can lead the better R2 score results. Experiment 3 achieved the best performance with an R2 score is 0.907x compared to the experiment 2, and the experiment 2 better than experiment 1. These were validated using the variance training sample set to test the model performance. And why? To achieve the best result, selecting the right machine learning algorithm at the early stage is important. In the experiment 2, select the correct features not only improve the accuracy, but also can reduce the model complexity and lead the faster training times. Finally, the boosting able for ML to focus on areas where the model are not performing well. In conclusion, combined with the experiment 4, which is the variance training dataset, and the experiment 3 did, which is combine the boosting, feature selections, decision tree regressions, allow us for the whole project achieve the best performance with the R2 score is equals to 0.9078. And thank you. This is my presentation.